Hello everyone. In this video, we will see how we can use Atom to create ELine services that transports a single VLAN using BGP signaling, using 802.1q endpoint interface types, and flexible Ethernet services as a physical encapsulation type. We will provision the connectivity fault management profile for this service. This particular model will also cater to multi-homing scenarios as well, where the CE will be connected to two different PEs and each will serve as a primary and backup path. Atom offers predefined service definitions in the form of a profile that one can choose from to create a particular service. A profile captures the commonly used parameters in a service. You can either edit them or you can create your own variation. Let us take a look at the service definition for a single VLAN Dot1q flavor using BGP signaling. Here we can see the signaling is set to BGP, the pseudo wire is set to Ethernet, and the instance type is set to L2 VPN. We can also see that the multi-homing is set to true in this particular case. In the connectivity settings, we can see the virtual circuit ID and MTU related configuration. The VC ID is set to auto pick from the resource manager in Atom IPAM. So we have already created a profile in the resource manager and that has been referenced here. Since this is ELine service based on BGP signaling, the RD is chosen as an auto pick from the resource manager in Atom. The MTU is set to 1522 and the MTU range bytes can be set as well. The PE-CE settings captures the configuration on the interface between PE and C devices. We have chosen Dot1q as the Ethernet option, and the customer traffic type is set to transport single VLAN. The VLAN normalization is set to swap, and the VLAN ID assignment is made automatic. The physical interface is set to flexible Ethernet services, and that enables us to set logical interface encapsulation to VLAN circuit cross connect. The MTU can also be defined under the PE and CE settings. Another important setting is the rate limiting parameter. We can choose the bandwidth and Mbps that will be configured as a firewall policy configuration. Let us now try to create a service. So we have the template loaded. Let's now take a look at the fields. The initial set of parameters include the name, the customer name chosen from the drop-down, and the service definition from the ELine profiles. In this case, we have BGP signaling and the multi-homing profile that is chosen. Then the CFM profile is chosen as well. In the connectivity settings, we can skip most of the details as all of them are going to be inherited from the chosen ELine profile. Endpoint A and endpoint Z will capture the PE device settings with respect to the CE device. We have the PE device, the corresponding UNI interface. The unit number is going to be an auto pick. The VLAN ID is also given as an auto pick from the resource manager in Atom IPAM. If needed, the bandwidth can be modified to a value different from the ELine profile. As this is a multi-homing scenario, we have enabled the backup settings. We have identified the backup PE and its corresponding UNI interface. The endpoint Z in this case will be a normal PE device with no multi-homing enabled. Let us now try to create a service. As you can see, a new service is now created. In the provision commands on endpoint A, the initial configuration is a firewall and policy configuration that has the bandwidth and then how it has been applied to the interface. We can also see the encapsulation configurations where we see VLAN circuit cross connect as the encapsulation type. Then we can see the configuration for VLAN translation. We can also see the routing instance configurations and the corresponding route distinguisher and route target values. Since this is a multi-homing scenario, we can see the site preference as primary and also the information about the remote site ID. This is the backup device that we had given as per the configuration. On the backup device, we'll have its own multi-homing configurations. We can see the site preference is set to backup on this particular site. We can also see the CFM configurations based on the chosen CFM profile. The second endpoint has similar configurations. On the device, we can see the same set of configurations. On the primary device, we can see the multi-homing configurations where the site preference is set to primary. We can also see the routing instance configurations including the RD and the RT values. We can also see the interface configurations, the encapsulation, VLAN configurations, the firewall and the policy configurations as well. You can also see the CFM profile attached to the interface, and here is the configuration for the OM protocol configuration for the CFM on the device. On the backup device, we can see the multi-homing configuration and the site preference is set to backup. We can also see the routing instance configurations as well. Rest of the configurations are similar to the primary. You can see similar configurations on the endpoint Z as well. Thanks for watching.